Hi, my name's Jeffrey Hanson. I'm a senior research scientist at Carleton University, working in Professor Joe Bennett's research group, and today I'm here to talk to you about the Where to Work tool. In our previous video, we talked about the key ideas in systematic conservation planning that underpin this tool, and today we're going to be talking about the terminology and functionality of the tool and providing an understanding of how this tool can identify priorities for conservation. Just to recap, the Where to Work tool aims to support the identification of priority areas for conservation. It helps explore and resolve trade-offs among different priorities and is grounded in the principles of systematic conservation planning. Put simply, if you can supply the data and articulate your objectives, this tool can help identify priority areas for meeting those objectives. This tool was developed in partnership between the Nature Conservancy of Canada and Carleton University. It's freely available online at ncc.carleton.ca, and the source code is available as open source on GitHub. Now let's start talking about the terminology that underpins the Where to Work tool. The first piece of terminology we're going to talk about is planning units. Planning units represent discrete spatial areas. These are places that may or may not be selected for prioritization. Critically, they are managed independently, meaning the selection or unselection of a particular planning unit does not necessarily depend on another planning unit. Examples of planning units include property boundaries, different sites or point localities, or spatial grid cells, where spatial grids can be defined using hexagonal or rectangular grid cells. When thinking about defining planning units for your case study, you'll really want to think about the case that's appropriate for your management decision and data uncertainty. For example, if you're working at identifying priority areas across Canada, you may consider using large-scale spatial grids at the 5 kilometre or maybe 10 kilometre scale. This might be appropriate given that your data might only be at a particular resolution that's relevant at these scales. But if you're working at a finer scale, such as planning across a city, you may wish to consider property boundaries because this is more directly related to the scale that you're working at. When selecting and defining your planning units for your prioritization exercise, you will also probably want to consider existing management areas. This is really important so that when you identify priority areas, these priority areas will build off and enhance existing management areas. And when you're defining your planning units, you may also wish to consider places that are not necessarily suitable for management, but contain important components of biodiversity. This is because the Where to Work tool allows you to specify your objectives using percentages. And so when you're defining a percentage, it's really important that the tool knows the full distribution of things, of the different biodiversity characteristics that you care about, in order that the percentages that you express are calculated correctly. We'll get into this in a bit more detail later on. Another key piece of terminology is feature. Each feature represents an independent facet of biodiversity. For example, features may include different habitat classes, so you might have one feature which is for forest, and another feature which is for shrubland, and another feature which is for grassland. You may also have different features based on different species, and you also have features that characterize ecosystem services, such as carbon sequestration potential or water purification. A group of features is called a theme. So, for example, you might have a theme that is related to threatened species, and inside this theme, each different feature corresponds to a different threatened species. When you're thinking about what features to consider in your analysis, here are some guiding principles. One is that a feature is a biodiversity facet of which its persistence is desirable. In other words, when you're selecting features, you want to select things that you want to persist in the long term. So this is why we might consider threatened species or native habitat types as features. For example, you would not probably consider an invasive species as a feature because you don't ideally want this thing to persist into the future. Features are also things that you ideally want covered by priority areas. So for example, you might have a land cover data, and this land cover data might have different habitat classes, including forests, shrublands, but it may also include a land cover class such as urban areas. You wouldn't necessarily include urban areas as a feature because you don't necessarily want urban areas to be covered by priority areas unless that relates to a specific objective that you have. When you're also thinking about selecting features, you need information on the spatial distribution of features across your system. So, for example, you might have presence-absence data for different species or habitat classes. You could have probability of occurrence or the relative amount or abundance of features in different planning units. So in other words, it's really important that you have mappable information for each feature. And this is important so that the Where to Work tool knows or has some idea on where these different features are found so that this information can be used to identify priority areas for representing these features in priority areas. Another key piece of terminology is goal. Goals are used to help specify your objectives for the prioritization. So what is a goal? A goal describes the minimum threshold level of representation by a prioritization that is required for a feature. So for example, you might set a goal of 30% and this for a particular feature, and this means that ideally the prioritization or set of priority areas should cover at least 30% of that feature's total distribution. Goals are also known as targets. Targets is more commonly used in systematic conservation planning, but for the purposes of the Where to Work tool, we refer to these as goals. Within the context of the Where to Work tool, goals are always set as percentages. And it's very common to have different goals for different features. And this makes sense because you might have some features where it's really important to ensure that their entire distribution is covered by priority areas. So for example, a threatened species that is only restricted to a very small area, you may wish to set a goal of 100% to ensure that this feature is fully covered within your priority areas. And that might be because you want to ensure the long-term persistence of this critically endangered species. On the other hand, you might have wide-ranging features, such as maybe a habitat class of forest, and you may wish to only ensure that a much smaller percentage of this feature is represented. So you might set a goal of 10, 20, or 30% for a forest class, for example, in order to reflect that this is not necessarily critically important to represent across its entire distribution. Typically, goals are set based on policy, statistical models, or expert opinion. In our previous talk, we covered about some of these strategies for setting goals, and so I encourage you to revisit that video if you want more information on that. For example, here we have a graph showing one strategy for setting goals. This is based on a scientific paper by Ana Rodriguez, and this strategy is designed specifically for setting goals for species at the global scale. The idea here being if a species has less than 1,000 square kilometers of its range in total, you would set a goal of 100%. And if the species has a range size larger than 250,000 square kilometers, you would set a goal of 10% of its distribution. And for species with intermediate range sizes, you would set intermediate goals using a log linear interpolation scheme. But this is just one approach for setting goals, and it's designed at the global scale, so if you were working at smaller scales, such as the national or subnational scales, you might want to consider a modified approach. Another key piece of terminology is weight. So earlier we talked about features, and we talked about goals. Features are things that you care about and want to represent in your priority areas, and goals let you specify minimum threshold levels for ensuring that features are represented in priority areas. Weights play a different role. Weights describe properties of places that can impede or improve conservation efforts. And you set factors for the weights to specify how much they will impede or how much they will improve conservation efforts. So goals are for features and factors are for weights. If we have a weight and we assign it a negative factor, we're saying that this weight will impede conservation efforts. And if we set a more negative value for the factor, then we're saying we'll have a greater impediment for conservation efforts. If we assign a weight a positive factor, then we're saying that this weight has the potential to improve conservation efforts. So here are some examples of weights. For example, you might have human population density as a weight, and because places with higher human population density may be associated with greater challenges for implementing conservation management, you might assign this weight a negative factor. In a similar way, you might also assign negative factors to weights based on land acquisition costs or human footprint index, because the conditions inside places with higher values, so higher land acquisition costs or higher human footprint index values, might be associated with greater impediments or challenges for implementing conservation efforts. On the other hand, we might have a weight that describes wilderness quality or wilderness areas, and here higher values describe places with a higher wilderness quality. And so as a consequence, such areas with a higher wilderness quality value might improve conservation efforts or make them more likely to be successful. And so we would assign a positive value to this weight. So when you're deciding what factors to set for weights, it's really important to think about how the weights relate to your particular objectives and what you're trying to achieve with your prioritization. What is your management decision and what are your objectives, and how these weights might relate to that. Another key piece of terminology is include. And include describes a set of areas that must be selected for prioritization. In systematic conservation planning terminology, we might refer to these places as being locked in for prioritization. And common examples of things you might use as includes might be layers or data sets describing the distribution of existing protected areas. The idea here being, if you set existing protected areas in your study system as includes, then these places will be selected automatically as priority areas, and any additional areas will aim to build on and enhance these existing protected areas. Now, this is really important because when you're identifying priority areas for doing additional or new conservation management, you want to make sure these new priority areas are going to be building off and enhancing what's previously been done. You don't want to be doubling up on work that's already been accomplished, because that's not very efficient. For example, you might have a study system where maybe 20% of your study area is covered by existing protected areas. These protected areas, they might cover maybe 80% of the distribution of a threatened species. If you have a goal that is to cover maybe 80% of this species distribution, then existing protected areas have already met this goal. And so when you're identifying priority areas, you don't need to be necessarily targeting places that have this threatened species, because that goal has already been met. And so if you were to identify priority areas without accounting for existing protected areas, then the new set of priority areas you identify would be inefficient and may not complement existing protected areas in a very efficient way. Another example of includes are places that have been earmarked or identified by alternative means as critically important for conservation. So for example, you might use key biodiversity areas as an include, because these places have already been identified by global experts as really important for conservation. And so as a consequence, when you're identifying your priority areas, if you have any priority areas inside your study system, that if you have any key biodiversity areas inside your study system, you may wish to ensure that these places are automatically selected, and so any other priority areas are designed to work around and build off and enhance these core areas. So when you're using includes, I would encourage you to run different scenarios where you disable or enable different combinations of includes, so you can see how different includes will alter your priorities, because you might find that certain places are only a priority if you don't consider particular includes, or if you do consider particular includes, and that might make you think about, are these really important priority areas, or are they doubling up on the potential benefits of existing management areas? Includes are also a really powerful way to account for stakeholder values, or particular areas that are particularly important for stakeholders. If you have stakeholders that have already identified places that they think are really important for conservation, if you obtain data describing where these places are, you can specify that as an include, And then when you're generating your prioritization will build off and complement these areas that have been identified by stakeholders. So for example, stakeholders might have identified 10 or 20% of a study area that's particularly important, and that might get you a lot of the way towards meeting most of your goals, for example, but it might not be fully complete in terms of meeting all the goals. And so this way, the Where to Work tool can help identify the last bits to fill in order to ensure that all your goals are met. And maybe your stakeholders have done and so by this way, the Where to Work tool can play a role in helping just to refine plans that stakeholders have developed rather than necessarily presenting or generating an entirely new prioritization. Another key piece of terminology is exclude. Now, excludes are the opposite of includes. So includes are places that must be selected for prioritization. Excludes are places that must not be selected for prioritization. So we commonly refer to excludes as places that are locked out for prioritization. And these might include places that have unsuitable conditions for conservation management. So they might be places that you've identified that have particularly high human pressure or land use values that are unsuitable for conservation. Or they could be places that have been identified by stakeholders as conflicting very strongly with their objectives. So for example, if you're working in a terrestrial system, you might have stakeholders that are interested in ensuring that certain agricultural areas are zoned for agricultural use. And so you might use a layer denoting these agricultural areas as an exclude to ensure that none of these places are selected for conservation management when you're using the Where to Work tool. So similar to the includes, excludes are a really powerful way of incorporating stakeholder values and considerations when using the Where to Work tool, because you can specifically say that certain places must or must not be selected as priority areas when using the Where to Work tool. Another key piece of terminology is budget. So in the context of the Where to Work tool, the budget refers to a pre-specified level of maximum expenditure for the prioritization, and it's specifically talking about the percentage of the total area that can be selected for prioritization. This is something that you specify as an input when identifying priority areas. So for example, you might specify a budget of 30%, meaning that the total priority areas in the prioritization cannot encompass more than 30% of the total area considered. This can be useful if you're trying to identify priority areas in line with national area-based targets, such as 30 by 30 or 50 by 50, or if you've got a specific budget in mind based on particular policies. Another key piece of terminology is spatial clustering. Spatial clustering, or its inverse, spatial fragmentation, describe the spatial arrangement of priority areas in the prioritization. Ideally, we would want to maximize spatial clustering because that is thought to promote connectivity and reduce the logistical challenges with implementation. The idea here with spatial clustering is that if you have priority areas that are closer together and form larger contiguous masses of conservation areas, this should promote connectivity because species and populations don't have to leave the priority areas in order to exchange gene flow and risk being affected by negative conditions outside the priority areas. This is also thought to reduce logistical challenges because conservation managers don't have to manage a large number of sites across a large area and can instead focus on fewer, larger sites. That being said, these are just rules of thumb, and there can be many cases where having a high degree of spatial fragmentation can actually promote connectivity and may also be more amenable for reducing logistical challenges. Spatial clustering is something you can explicitly account for in the Where to Work tool by specifying a parameter that controls your preference for spatial clustering, but it's worth noting that explicitly accounting for spatial clustering in the prioritization step will increase runtime. So this means if you have a particularly large problem, such as over 100,000 planning units, you might find that this is not really, the runtime required to solve such a problem may not be feasible. The Where to Work tool identifies priority areas by solving optimization problems. So once you've specified all your data and all your parameters and all your goals, your targets, your factors, all this information is condensed into an optimization problem, which the Word-to-Work tool will then solve to identify priority areas for conservation management. When you use the Word-to-Work tool, it can do this by using one or two problem formulations, and this depends on whether you specify a budget. If you specify a budget as part of your input parameters, then the Word-to-Work tool will use the minimum shortfall formulation. If you don't specify a budget, then the Word-to-Work tool will use the minimum set formulation. And the type of problem formulation that used will have an influence on what the priorities that it will output are. So now I want to go over just briefly what these formulations are and how they express the potential benefits, conservation benefits with alternative schemes, and what parameters are considered. So the minimum set formulation aims to find the cheapest solution that will meet all the goals for all of the features, and it's constrained by these goals for biodiversity. So what that means is it's going to try and reduce the total cost of the priority areas as much as possible, but it's always going to try and meet these goals. So what that means is it's never going to return a set of priorities that doesn't meet the goals. So you can think about this as a biodiversity first kind of planning approach where you're identifying priority areas that will always meet the goals. But and the thing that's being varied here during optimization is how much the cost is. The minimum shortfall formulation is the opposite. This formulation is constrained by the budget. So this means that if you specify a budget and so the minimum shortfall formulation is used during optimization, the Word-to-Work tool will never return a solution that exceeds the budget. So this is really important because if you set a really low budget, then it may not be possible for it to return a solution that may be even close to meeting your goals. And so if you're using a budget, you want to think carefully about what an appropriate budget is, or consider trying a range of different budgets. When deciding between competing solutions during the optimization process under the minimum shortfall formulation, the prioritization will try to find the best solution based on trying to find the solution or set of priority areas that gets as close as possible to meeting the goals for as many features as possible. But unlike the minimum set formulation, when you're using the minimum shortfall formulation, it's not guaranteed to meet these goals. And in many cases, it's not going to actually return solutions that meet these goals. So let's go over this in a bit more detail just to see how this works. So let's pretend we have a very simple kind of case study here. So you're in charge of managing a set of islands, and across this set of islands you've got a variety of different populations. So for example, we can see that we've got some islands that have penguins on them, a couple of islands have elephants on them, and a couple of islands have goats. So under the minimum set formulation, what we're going to do is we're going to be saying our mathematical objective function is to minimize total cost. And what we're going to do is we're going to say each island costs unit 1 cost. And in our constraints, we're going to say that we must meet all the goals. And our goals here that we want to protect at least one population of each species. When you're using the Word-to-Work tool, these goals are expressed as percentages. But just to keep things simple, we're going to specify these goals here in this example using numbers of populations. So here our objective is to minimize total cost, and each island costs the same. And our constraints are that we have to meet all the goals, and our goals are that we want to get at least one population for each species. Given this problem formulation, the optimal solution would look like this, as shown in the yellow circled islands. And this is because by selecting these set of islands, we can ensure that we get at least one population for each species, and this minimizes the total number of islands selected and would be associated with an objective value of 3 because each island costs the same, has a unit 1 of cost, and we've got 3 islands, so 3 times 1 is 3. This is the kind of optimization formulation that the Word-to-Work tool uses if you don't specify a budget. Now let's look at the minimum shortfall formulation. Here our mathematical objective function is to minimize the percentage of each goal that is unmet and then sum those together. This is a bit more complicated, but we can see here that we've also got constraints, and our constraints are that the total cost must not exceed the budget, must be lesser than or equal to the budget. Similar to the previous example, let's assume that each island has a unit 1 cost, And now let's say that we're going to specify a budget of 4. So what this means is we can have no more than 4 islands selected in our optimal solution because each island has a unit 1 cost. Here, our goals are going to be that we want to protect all of the populations for each species. So this is a bit more complicated and we can't immediately spot out what the optimal solution would be, but I ran this using the Where to Work tool and this is the solution that we got. So let's kind of work backwards now from this optimal solution to work out why this would be the optimal solution. So we can see straight away we've got 4 islands selected. So we've met our constraint of that our solution cannot cost more than 4 cost units, or in other words, select more than 4 islands. And we can see that we've selected a set of islands that meets the goals for several of the species. So for example, our goals were to secure 100% or all of the populations for each species. And we can see here that we've met the goals entirely for the penguins because there's 1 population of penguins and we've selected that island which has that population of penguins. We can also see that we've met the goals for the butterflies because we've secured all of the populations of butterflies. And we can also see that we've met the goals for the goats because we've secured all of the goat populations. We can also see that this particular solution has met half of the goal for the elephants because there are 2 elephant populations in total and we have 1 of these 2 populations. So when calculating the objective value for this particular solution, what we do is we calculate the percentage of the goal for each species or feature that is not met and then sum them together. So for example, we can see for the elephants, we've got 1 of 2 populations. So what we can do is we can calculate that we've met half of the goal, so 1/2, and then to calculate the percentage of the goal that is not met, we subtract 1, we do 1 minus that number. So we would do 1 minus 1/2 to calculate the proportion of the goal that is not met for the elephants, which is 50%. We can see for the penguins, because we've met the goal, we would have 1/1 as the fraction of the goal that is met. And so you would do 1 minus 1/1, which is 0, meaning that we've entirely met the goal for that species. In a similar way, we would do 1 minus 1/1 for the butterflies because there is 1 population of butterflies and we've secured that population in this solution. And so we have 0% of this species goal that is not met. We can see for the crabs it's a bit different. Here there are 2 populations of crabs secured in the solution, but there are 6 populations in total. So what that means is we've met 2/6 of the goal. So the proportion of the goal that is not met is 1 minus 2/6. So we can calculate these fractions for each of the different features and then sum them together. So we can see that we've got 50% of the elephants, 66% of the crabs is not met, 0% of the butterflies is not met. So we take those percentages, sum them together, and that gives us a value of 1.1. And this number describes how good the solution is. And this is trying to be, and when we run the Where to Work tool, it's trying to minimize this number as much as possible. If this number was 0, then it would mean that we've met all the goals for all the features. But because it's greater than 0, this means that there are some features that have some of their goal that is not met. So when you're using the Where to Work tool, there is uncertainty and limitations to be aware of. This is because the quality of the priority areas that it can identify depends a lot on the quality of the data that you provide. So in other words, garbage in, garbage out. And so when you're using the Where to Work tool, I would really encourage you to try and get access to high quality data that's able to characterize the spatial distribution of your features as well as possible. It's also worth noting that the prioritization that the Where to Work tool will output depends a lot on your objectives. So this is articulated based on your feature goals and your weight factors. And so different values for feature goals or different values for weight factors will have an influence on the priorities that it identifies. And so what this means is, depending on what parameters you use, you will get a different answer. And so if you're uncertain about what an appropriate goal or what an appropriate factor would be, I would encourage you to try running different scenarios with the word work tool, where a scenario corresponds to a specific combination of goals and weights. And so by doing multiple different scenarios and multiple different runs of the word work tool with different values, you can get a sense of how sensitive the priority areas are to these different parameters. Now, that might sound like a lot of work and it could be potentially confusing to interpret, but one thing I would suggest is that often when you're using the word work tool and you're varying goals and weight factors, you might find that there are certain places that always emerge as so places that are always selected in most of the different scenarios. And these would be places where you can be fairly sure that they're a priority regardless of this uncertainty and what maybe the best goal or best factor is. So for example, in this figure, we've got a situation where someone has identified a range of different priorities based on different scenarios. So each different panel represents the different scenarios and the colors show the relative priority, where blue colors are highest priority. And we can see there are certain places that are shown in blue across all of these panels. And so these would be places that are fairly robust. So these would be priorities that are fairly robust to that uncertainty across different scenarios. So thanks so much for listening to me. If you have any questions about the Word at Work tool, I would suggest reaching out to Richard Schuster. I've put his email on screen. You could also have a look on the Nature Conservancy website as well. And just here are some links again. So ncc.carleton.ca is where you can access the Word at Work tool. And here's the GitHub link, which has the source code for the work tool as well. In our next video, we'll be actually using the Word at Work tool and showing how you can use it to identify priority areas. So thanks for listening, and I hope to see you in the next video. Bye.